Let's look at final exam question number 82 in Physics Demystified, second edition. If you have the printed book, you'll find it on page 533. Consider a solid object. Well, here's our solid object. It's a spaceship, kind of looks like. And here are you. And there is your little table with your little cup of coffee, which you have already consumed so nothing will spill out. And of course, all of this is anchored down so that it doesn't float around in there. It's traveling in a straight line through interplanetary space. We will inevitably see acceleration if one of the following four things changes: mass, speed, weight, or density. Well, the mass may change. I don't know how. I mean, maybe you discharge. I didn't draw the toilet in here. Maybe you flush your toilet into outer space, thereby changing the mass of your spaceship. Will that inevitably cause acceleration? No. If you're just coasting, won't have any effect at all. How about weight? Choice C. Well, that would be inapplicable here, because in interplanetary space nothing has any weight, assuming the gravitational acceleration is zero. So that won't happen. It'll be zero. The weight is always zero. If you added weight, that's an oxymoron here. How about density? Well, again, if you flush your toilet into outer space, your entire ship will become just a wee bit less dense, but it isn't going to inevitably cause you to accelerate. But if you start up the engine and thereby increase your speed, or if you fire a retro rocket from the front and decrease your speed, if you change the magnitude of this vector, this velocity vector, if you change the magnitude of that, you will inevitably have acceleration taking place. And that particular answer in here, that speed is the magnitude of the velocity vector. Velocity vector comprises speed and direction. Well, it's a straight line in some direction. If you change the speed, you change the magnitude of this vector, thereby inevitably producing acceleration. You fire the rocket, the acceleration vector will be in the same direction as your velocity vector goes. If you fire a retro rocket to slow down while you continue along in a straight line, your acceleration vector will go backward, exactly contrary to the velocity vector, even though the velocity vector will continue to point in that direction. But the correct choice for this particular question is B. The object will inevitably accelerate if it experiences a change in speed.